Hello everyone, welcome back to another video on Microsoft Orleans. In this video we're going to take a look at using timers and reminders in Orleans. So these are things we can use to schedule some periodic work that we want to occur over and over again. And in our specific banking application, what we're going to use them for is a sort of recurring payment or direct debit where someone's account gets debited every X minutes or X hours or X days. That's the kind of functionality we're going to build. If you're liking this series or you want to check out more videos on distributed application development, don't forget to subscribe to the channel and hit the bell notification icon so you get notified for new videos. Let's take a few minutes to discuss the difference between timers and reminders in Orleans before we go ahead and implement them in our code. We will show how to implement both in our code, but we will actually only be using reminders in the final code base, as I actually couldn't think of a good enough use case to use timers in our banking application. If anybody can think of some good use cases, please feel free to leave them in the comments. So as we know, both timers and reminders are used to perform some work that we want to do periodically. This could be things like recurring payments, session timeouts, or really anything that needs to occur after a certain period of time has elapsed. At a simplistic level, both are a good choice for doing this type of work, but there are obviously some important differences between them. One of the core differences is that callbacks from timers are not delivered as messages. Their execution is interleaved with other requests for the grain, resulting in the possibility that the grain is executing two pieces of code at once. So if we're using timers, we need to be more careful about what code we are executing in their callbacks and ensuring that it works well concurrently. Reminders, on the other hand, act in the same way that grain method calls work. They produce a message that is consumed by the grain. That means that the code triggered by a reminder needs to wait until the grain is finished processing other messages to execute. It's the same the other way around. If we have reminder code running, then other messages, say from a client call or a grain-to-grain communication, need to wait until the reminder finishes before they can be processed. Timers also don't affect the activation state of a grain. This means that they can't be used to keep a grain active. For instance, say we have a grain that will be deactivated after 20 seconds. Even if we have a timer running that triggers a callback every 5 seconds, it will not renew this 20 seconds, and so the grain will be deactivated after the 20 seconds has elapsed, and no more timer callbacks will occur. Reminders, on the other hand, can reactivate a grain that is deactivated and can renew the grain's activation period, making the grain remain longer for active or even indefinitely. One of the most important distinctions between timers and reminders is how they deal with persistence. Timers are not persisted, which means that if a grain fails or deactivates, the timer is lost, and no more callbacks occur. Even when the grain reactivates or the cluster recovers, the timer will not begin to run again and will not execute any more callbacks until we explicitly re-execute the timer. Reminders, on the other hand, survive grain failures and deactivations and continue to receive callbacks after these have occurred. The final main difference is around how frequent we can run the callback code for a timer versus a reminder. Timers can be used for high frequency, periodic work, while reminders cannot. Reminders can only be triggered, I think, once every minute, while timers have much lower granularity, even seconds, milliseconds, or below. If we did want to achieve a combination of high frequency but a persistent periodic work, one of the common strategies is that we use a timer, say with a second granularity, to run the callbacks and actually run the work. And if that dies, we have a reminder running that will automatically reactivate the timer. So let's jump into our code base and see first how we can implement a simple timer in the code, and then how we can implement a reminder. Okay, so we are back in Visual Studio, and let's look at implementing a really simple timer, say on our checking account grain. So we're just going to trigger this timer when we call credit for now. We're not going to leave this in the code. This is just to demonstrate how a timer would actually work. So to run a timer, or to register a timer, I guess, we just call the register timer method, which is on the grain class and the abstract base class. And essentially we need to pass this a couple of things. We need to pass the callback, some state we want to pass to it, the due time, and the period. So the due time is the first time we want the timer to run, and the period is then how regularly we want it to execute. So we can just pass the callback here, state, and then for now we're just going to pass no state into the timer, and we're going to use time span from seconds. So it's going to run after 5 seconds, and then it's going to run every 5 seconds afterwards. So it's going to run every 5 seconds, essentially. And we can put the code that we want to execute here. So let's just add some really simple logs. Obviously, in reality, you'd probably want to use a logger rather than the console, but just to keep it simple, we're going to use the console, and we're just going to write starting timer and ending timer. And then to simulate some work in the middle, we might just do a wait task.delay time span, and we'll delay the execution of this method, say, for 5 seconds. And we'll actually run this every 10 seconds. So every 10 seconds, this timer will run, and it will take 5 seconds to run, essentially. And the first time it will run will be 5 seconds after the credit method is called. Simple. And just to demonstrate how we can actually call the debit method while this callback is running, we're going to add some logging into the debit method as well. So, and we'll remove all this code in a minute, but we might just have starting debit here, ending debit, and then we're also going to add a wait here. But we're going to wait here for longer, so we're going to wait for 20 seconds. And we'll see in the code that this timer will continue to execute even when we call the debit method and the debit method is executing. And the same with vice versa. If we call the debit method even while the code is in here, this will continue to run. And that's generally not how Orleans works. We generally can only have one piece of code executing on the grain at a time. So let's run our cluster, and obviously don't forget to run Azurite before you do it. So we're just going to restart our cluster here with this new code. We're going to go into Postman. We're going to open up the console and just take a look at what we see. Okay, so here is the console window, and off screen, I'm just going to call the credit on the checking account that we created yesterday. So we should see after 5 seconds that we get the timer starting. And then after about 10 seconds, this will end here. And then after another 10 seconds, we should see that appear again. And that should happen until the grain deactivates. And I'm also going to just queue up a call to debit here. So once this ends, we should be able to call debit. And we see we're starting the debit. But we'll see the timer in the meantime also trigger its callback even while the debit is happening. We can see there that this has actually executed before this is finished. And the same happens the other way around as well. So we've ended the timer, and we're going to end the debit shortly. There we go. And we're starting another timer, and if we send another request to debit, we can see that we started the debit even though the timer was already running. So that just demonstrates how timers don't kind of produce messages. They don't force only one piece of code to be executing at a time. So you need to be careful with concurrency when using timers. So let's stop that. Let's just remove this code we've added, and let's take a look at adding a reminder next. And the reminder we're going to add is for a recurring payment. So we're going to leave that in the code base as that's some sort of functionality that we want to keep. So next, we're going to look at implementing the recurring payment reminder on our checking account grain. So this is just going to debit our account with a certain amount every X seconds or so, or every X minutes, I guess, in the case of a reminder that can't occur that frequently. So we're going to split this into a couple of different parts. We're going to do the bit in the silo, then we're going to do the bit in the grain, and then we're going to do the bit in the client. So the part in the silo is pretty straightforward. The main thing we have to do is we have to add another provider to allow us to use reminders on this silo. So this is the same way that we configured the storage. We just have to use the silo builder and add some extension. And we also have to choose a provider for this. We're going to use the Azure storage provider, the same one we did previously. So we're just going to continue to use Azure storage, but there's also different versions that use DynamoDB, Cosmos DB, and even an in-memory one for development. So the first thing we're going to do in our silo is just going to add the NuGet package we need. So we're going to go to manage NuGet packages, and we're just going to search for Orleans reminders. And we can see here that we have a lot of different ones. Like we said, Azure Storage, DynamoDB, Redis even. We're going to use the Azure storage one, so we're going to just install this one on our silo. Again, using the version 8.1, but hopefully at the time, the latest version is suitable for you. And once that's done, once we have that package installed, we just want to configure to use it in our program CS in our silo. So we do silo builder, and then use Azure table reminder service. And we want to go configure options, and then in this func, we want to say options.configure. And in here, we want to set our table service client equals to the same table service client that we've been using the development connection string. There seems to be an issue here. I think I am probably just missing some brackets. We're using the blob one. Sorry, so it should be the table service client. Azure data tables, perfect. And our semicolon. And that's essentially all we need to do in the silo. So next time we restart the silo, we should be then able to use any reminders that we want to add on our grains that are configured to use that silo, and we can get started with it. So next, let's jump over to our actual checking account grain, and let's start to do the implementation here. And again, this is a little bit more hands-on than a timer, but obviously it's persistent and there's a lot more complexity to it. So the first thing we want to do is go into our checking account grain, and we just want to add another method to add this recurring payment. So we just call it add recurring payment. And we might want to pass an ID for the recurring payment. We might want to add an amount that we want to debit by each time, and a value for how often it recurs. So it recurs every minute. So perfect. So once that's added, then we can go and jump into our checking account grain. We obviously need to implement that method. And another thing that we need to do is we need to implement the iRemindable interface. But before we do that, we want to install a NuGet package to allow us to use these reminder abstractions in our grain. So if we go to, on our grain, if we go to manage NuGet packages, and we just again search for Orleans reminders, what we want to install in this case is just microsoft.orleans.reminders. So we don't need to install the specific versions for the underlying technology we're using, just the kind of core reminders package. And once that's installed, we can then implement iRemindable. And then we want to implement that interface as well. And we can see here that this is the receive reminder method that we'll implement in a second. I'll just drag it up to the top. This is what actually gets called when our reminder triggers. Well, this is where we're actually going to trigger our reminder. And we want to probably store our recurring payments in state. So let's go ahead and add the necessary classes in our state folder here to make that happen. So let's just add an object called recurring payment here. And again, we can make this a public record. Like all of our other state classes, we want this to be serializable. So we'll go generate serializer, and we probably want to have the payment ID, again using a setter, a decimal for the payment amount, and then how often it occurs. So in reality, we probably would want to store a lot more information here, like last time it ran and different things like that, but we're not going to do that here. We're just going to keep it pretty simple, and we'll just add these attributes to make sure everything is serializable correctly. Perfect. So that's it added to our state, and we actually want to just add this. We're not going to add a brand new state object. We're just going to reference this in our existing checking account state. So we'll add another variable there, ID3. It's going to be a list of recurring payments. Let's call it recurring payments. Again, a getter and a setter. And we'll just default that to a new list of recurring payments. Perfect. So now we can store these recurring payments in state. So let's jump back to our checking account grain and let's start to implement this add recurring payment. So two things we want to do here is we just want to store the recurring payment in state, and we'll see why we want to do that in a minute. And the second thing is we want to actually kick off our reminder. So we should definitely add some validation and stuff here, but just for the sake of time, we're not going to do any validation or exception handling. Definitely recommend you do that in your own application. But for now, we're just going to get the checking account state, we're going to get the state, and we're going to get the recurring payments, and we're just going to add to that. So we're going to add a new recurring payment to represent the one we're going to add. ID will be the ID, the amount will be the amount, and occurs every minutes will be recurs every minute. Obviously, naming is not as consistent as it could be there. And then we just want to call await checking account state dot write status sync. So nothing new here, exactly what we did in the last video, just adding something to state. But what will be new is registering the reminder for this to happen every X seconds as defined in recurs every minutes. So we go await this, and we just want to call register or update reminder. And this takes three parameters: the reminder name, the due time, and the period. So quite similar to the timer, except it just doesn't take a callback or a state. It's the reminder name, that's the difference. So we want to give this a unique reminder name. So what we're going to do is we're going to add some constant at the front. So we'll call it recurring payment, and then some sort of delimiter. And then we want to use the payment ID to uniquely identify this payment. And then we need to add the first time it occurs. So after how many minutes will it occur first time? So we'll do time span from minutes, recurs every minute. So this will occur after that amount of time. And then from then on, it will recur after the same amount of time. Obviously, if you wanted to start the reminder sooner, you would set this to a lower value. If you wanted to recur different from the time the first one calls, then change that as well. We're just going to use the same for both for simplicity. That's essentially it in our recurring payments. So that just allow us to register a reminder. Now we need to just look at what we want to do when the reminder actually triggers. And the core of that is in this receive reminder method that we need to implement because we're implementing the iRemindable interface. So we'll start off by just making that async. And this method is what gets called for like all the reminders. So every single reminder that we have, whether it's for recurring payments or other methods we might have in the future, will go through this method. So we need some way to just pull out our recurring payment reminder from other ones. And again, in a production application, this might be kind of complicated handler or dispatch code. We're just going to do something quite simpler here. We're just going to say if reminder name, and it starts with, again, this recurring payment we added here, which probably should be a constant, but for now we'll just do it here. So we'll now know that our recurring payment will go in here. And we might want to just parse out the ID of our payment. So we're going to say var recurring payment ID. And the reason we're doing this is we just want to get our recurring payment from the state we set. So we set the recurring payment state here, and then every time the reminder triggers, we want to just pull that bit of state out. And we want to parse the GUID here. So we know we have the payment ID as part of the reminder name. So we go reminder name inside GUID.parse. Excuse me. And we split that on the delimiter we added. So we added this delimiter again, probably should be a constant. And we know we just want the last bit of it. So not toString, we want last. Perfect. So that will get us, hopefully, the recurring payment ID. Might be some exceptions there. Obviously want to handle them in a production app, but here, I think that will get us where we need to be. And then we just want to retrieve that recurring payment. And we just want to do that the same way we read state all the time. So we want to say checking account state, state, recurring payments. And we're just going to get one of them. And we want to say, we want to get the one where the payment ID is equal to the recurring payment ID. We're just using the link here to get that. Cool. We've now got the recurring payment. We've received the reminder. Last thing we want to do on our grain is we actually want to debit the account. So we can just call the debit method that we have already added. We want to just take the amount we want to debit, which is on the recurring payment. Here. and it's called the amount. Perfect. And we just want to await that. Perfect. So we should receive the reminder. We make sure it's a recurring payment reminder. And if it is, we parse out the ID. We retrieve the recurring payment from state, mostly just to get the payment amount, and then we debit the account by that. If we had other reminders, we might have other if statements here, or we might have some more complicated kind of dispatching or handling code. So that, I think, is everything we need to do on our grain. The last bit we need to do is just implement some code on our client so we can actually call this add recurring payment method through our HTTP API, which uses the Orleans client to call our checking account grain. So let's do that next. We'll start by adding a contract. And we're just going to add a new API contract. We're going to call it create recurring payment. Super easy. Public record and a data contract. And we'll add a couple of fields here. We'll add the payment ID. We will add the payment amount, which is obviously going to be a decimal. And we will add the payment recurs every minute. Perfect, and that will be an integer. These can all be init only. Like any API contract, best to make it immutable. Perfect, so that's our create recurring payment. So let's go back to our program class here in our client. And just note, we didn't mention it, but we don't need to add any new packages here. Again, this is just a really lightweight ASP.NET Core client. This is really just abstracting Orleans away from us. The only thing it needs really is the Orleans client, and then lets the silo do all the work. So let's go down to our checking account methods. Let's start actually by just copying this one we have for the credit. And we will use the same kind of route. So we want to get the checking account ID. We'll just call it recurring payment. We want the checking account ID and we want the create recurring payment body. We still want to use the cluster client, obviously, because we want to call our cluster. We want to get the checking account grain, but we want to use the add recurring payment method here instead. And that will take the properties from the create recurring payment, the ID, the amount, and how often it occurs. Perfect. So I believe that is everything we need to make this run and actually set our reminder. Okay, so let's run our cluster again. Start up our silo and start up our API. And let's call this new endpoint we've added for recurring payment. We'll use Postman to do that as usual. And we'll actually create a new checking account first. See what the balance is, schedule a recurring payment, and then check it every so often to make sure it's behaving as we expect. So we'll open up Postman here. We'll go to initialize checking. Again, we'll open it with a balance of 500 this time. We'll send that. Looks to have created correctly. Let's get the ID from the headers. So here we go. Let's get the checking balance. Should be 500. It is. And let's schedule this recurring payment. So just want to change the ID up here. And again, apologies for the small text here. I know it's hard to see, but we're just calling the recurring payment that we added and the endpoint that we added. We're just adding the ID of the checking account we just created. We can use any payment ID here. We're going to change the payment amount to 10 and it's going to recur every 2 minutes. So let's send that. It looks like it has worked. No exceptions anyway as of yet. And let's check the checking balance again. Should still be 500. But every 2 minutes, they should drop by 10. So we'll come back here, 2 minutes time. We'll see what this has dropped to. Okay, so around 2 minutes has passed. Let's just call our balance endpoint again. And we can see, as we expected, it's dropped to 490. So 490 euro, dollars, whatever. And if we wait another 2 minutes, we'll do it one more time. I'll edit it out so you guys don't have to wait. We should see this going to 480. And just while we're waiting for that, one thing that we could do with both timers and reminders is just kill our cluster while they're running. And with a reminder, when we restart our cluster, we should see that the reminder continues to tick over. So this continues to drop to 480 to 470. Well, if we had done this bit of code with a timer, it would just stop. So it would never go below 490 until we scheduled that recurring payment again. But because we've used reminders, our cluster can stop, our grain can deactivate, different things like that can happen. We'll be resilient. Let's just give it another minute and we'll see when we drop to 480. Okay, so around about another 2 minutes has passed. Let's just call this endpoint again to get the balance. And as expected, we can see it's dropped again to 480. So that will continue to drop while our cluster is running till it reaches 0. And in our case, because we haven't had any validation logic around the amounts in the count, it will continue to go negative, I guess. So thanks for watching this video, guys. Hope you learned a lot about timers and reminders in Microsoft Orleans. If you're enjoying the series or you want to learn about other distributed application development topics, don't forget to subscribe to the channel, hit the bell notification so you get updated for our latest videos, and don't forget to like the video as well. Thanks.